Graphing a piecewise function can be really intimidating, but once you learn how to read the notation, it starts to look more familiar and it's really not that bad. The important thing to remember is that a function is a relationship between inputs and outputs. So when we input an x value from the domain into the function is going to define some kind of rule or calculation that we're going to do with that input, and the result is an output. It's part of the range. So when we plug in an x value and follow the calculation, we get a y value, and that forms an ordered pair that's on our graph. What makes a piecewise function so intimidating is that there's several rules to follow within one function. This piecewise function has 3 different rules or calculations to follow based on 3 different sets of inputs. For this first rule right here, we're going to follow -4 minus 2x for all of the inputs that are less than or equal to -1. So when I look here on my x-axis where the inputs are, here are my inputs that are less than or equal to -1. And when I input a value, say for -1 into my function, the output is the height of the function. So the output is either going to be above or below, that input based on where that function sends me. Same thing with all of these inputs. So that first rule, the graph of all the outputs, is going to be in this area somewhere. So this piecewise function is basically going to section off my graph into 3 different sections based on these 3 different rules. For the second rule, we're going to do the calculation x plus 2 for all the inputs between, but not including, -1 and +3. So inputs like 0 and 1 and 2, all the way up to 3, but not including it. For those inputs, we're going to follow the rule x plus 2. So when I plug in 1, for example, I'll do 1 plus 2, which will send me to 3. So the inputs are going to send outputs either above or below those values in this area. So the next section of the graph is going to end up in here somewhere. Okay, based on the calculations we do and where the function ends up sending those inputs. Okay, and the last part of this piecewise function, the last rule says the calculation is just 7, and we'll talk about that for all the inputs that are greater than but not equal to 3. So inputs like 3.1 or 4 or 10, anything on this side. So the next part of the piecewise function is going to send the graph in this area somewhere. Okay, so let's talk about how to graph these suckers. So let's look at our first rule. We can graph this by plotting points, or you might notice that this is a linear function. But let's start by plotting some points. So let's say, for example, that let's plug in the endpoint here. Let's plug in -1. Because I want all the inputs that are less than or equal to -1, so let's make it equal -1. If I put -1 into my function, I'm going to follow this rule. So I'm going to get -4 minus 2 times -1. That'll give me -4 plus 2, which will give me -2. So the ordered pair -1 comma -2 is going to be included, since the -1 is included, it's going to be included in that section of the graph. So I'm going to put a solid point for -1 comma -2. So -1 comma -2, solid point right there. Now let's put another input in. Let's put in -3. So if I put in a -3 into my function, okay, -3 is less than or equal to -1, so I'm going to follow this rule. So I put in a -3, that's going to give me -4 plus 6, that's going to give me a +2. So the ordered pair -3 comma 2 is going to be a solid ordered pair on the graph. So I'm going to come here to -3 +2, solid point. And I know this is a linear function, so I'm going to be able to connect these guys with a line. I could have also used the fact that it's linear to sketch this by doing the y equals mx plus b process, picking out the slope and the y-intercept. So The y-intercept here is -4. So the y-intercept in my equation would be 0, -4. And the slope is a -2. So the slope would be a -2/1. The problem with this is that I only want to graph the part of the line that ends up in the yellow section. And when I go to graph this, 0, -4 is here in this orange section. So I wouldn't want to graph that y-intercept because it's not part of the domain, which is here in this yellow section. But if I go up to over 1, then boom, I hit the yellow section. Then I can start drawing my line up to backwards 1, up to backwards 1. Note that the slope is really telling me down to over 1, but if I go down to over 1, I'm going to be in the part of the line that's not part of the inputs. It's not part of the domain. So I don't want to draw the line going that direction. I want to kind of backtrack and start drawing the line where the domain is included. So similarly, we can look at the next rule. The next rule is x plus 2, and that's for inputs between -1 and 3. So for example, let's say we want to input, let's input 1, -1. So if I want to input -1, then, but it's not included. I'm not going to include this, so I'm going to put a little note here. Not included. Because see how it's not really equal to -1, but I can get really